Welcome back to some more geometry. Today we're talking about angle relationships. Let's look what we got going on today. So, as we talked about in the last section, angles are formed of two main things. Rays. Ray 1, which is we call that a side. Ray 2, side. And where they meet, the common endpoint is a vertex. Okay? So we talked about a little bit about adjacent angles. There are angles that are right next to each other where they share one side. So for example, angle 1 right here is adjacent to angle 2 over here. They share this ray and this vertex right here. Angle 4, since it has the number 3, we can call it angle 4. We can also call it angle AXB because the X represents this point right here. So it has two different names. This angle right here, angle 4, is not adjacent to 7. These are not adjacent. Why not? Because the only thing they share is this vertex. They don't share a side. They only share the vertex. So that's very important. They have to be right next to each other. Now, angle 4 right here is adjacent to angle AXF. Okay, so that we can say. All right, so that's adjacentness. Let's talk about linear pairs. Now, 2 sections, we're talking about linear measures, 3 sections, linear measures, where we're talking about lines. So a linear pair is a pair that are adjacent to each other that ultimately make a line. In this case, as it says, is a pair of adjacent angles when non-common sides are opposite rays. So this angle right here, angle 2 and angle 1. Okay, those are the 2 angles. This is the common side they do share, and these are the non-common. We do those in red. The non-common sides are opposite of each other, making this straight angle, making this whole thing. How much is the class? Yes, 180 degrees. 180 degrees. So if we know that these 2 angles together is 180 degrees, what is the value of x? How are we going to do that? Well, first things first is we don't know what they are individually right now, but we know that this plus this make 180. So that's what we're going to say. We're going to say x plus 44 plus 7x minus 248 equal 180. All right, let's do a little bit of math. So we get x plus 7x equals 8x. 44 minus 248 equals negative 204. That equals 180. And then we add 204. We got to get x by itself. So plus 204. We get 8x equals 384. And then you divide by 8. What does that give us, class? So 8 goes into 384 times. The remainder of 6. 8 goes in 64. 8 times. X 48 equals x. Easy peasy. Remember, 2 angles were the lines, opposite lines, or 2 rays. 2 angles, yeah, I was right. 2 angles that are adjacent to each other where they form a line equal 180 together every time. Let's talk about vertical angles. Now, vertical angles is my favorite thing about vertical angles. This is always true no matter what. They are always congruent. Vertical angles are always congruent, meaning the angles are congruent to each other. Their values are equal. Their measurements are equal. So vertical angles are angles that are not only across from each other, but the only thing they share is a vertex in this case. Now, for example, let's go back real quick right here. These 2 are not vertical angles. Now, they are angles across from each other, but not vertical. Reason being is that they're, as it says in vertical angles, they're 2 non-adjacent angles formed by intersecting lines. 2 lines, when this did not go all the way through. This one went all the way through, but this one stopped right there. So we can't say the lines intersected completely. They're not lines. Here, though, these 2 lines intersected, forming these 4 angles. Well, this angle is congruent to this angle for sure. Without even knowing the measurement, that's for sure. Also, this angle 8 is congruent to this angle 6 for sure. Now, we do know that this is 90. If this is 90 and these two are a linear pair, that's 90. And if these two are a linear pair, that's 90. And if these two are a linear pair, that's 90. So that's very important. So same thing right here. 1 and 3 are congruent. 2 and 4 are congruent. 9 and 11 are congruent. 12 and 10 are congruent. That being said, what's the value of x in this problem over here? We know that angle 1 is 120 and angle 3 is 2x minus 10. Well, what did we say about 1 and 3? They are congruent. So if they are congruent, their values are equal. So we'll set them up. Angle 1 is equal to 120, so 120 is equal to the measurement of angle 3, which is 2x minus 10. Minus 10. So we got to get x by itself, so plus 10, plus 10. You get 130 equals 2x divided by 2, 20, start by 2. Not 20, that's 2, 2x. 2x divided by 2, you get 65. 65 equals x. That's the value right there. Next one up, let's talk about complementary angles. So there's two things we're talking about. We're talking complementary and supplementary, and for some reason we get those confused. So let's do our best now to complementary angles are of course two angles whose sum is 90. Okay, complementary angles equal 90. So this angle right here and this angle right here are complementary because together they make 90-degree angles. But they don't have to be adjacent like that. Angle, we could say, hey, angles, this angle right here, 60 and 30, they're complementary angles. Why? Because they equal 90 together. So they don't have to be adjacent angles to be true. But that being said, if you know this is a right angle, because it equals 90, and this is 37, to figure out angle x, we just take 90 minus 37. That gives us the value of x, which will be what, class? 60, 53. Now, supplementary angles against our two angles, but this time they equal 180. So just like before, a linear pair can be supplementary because together they make the line, but they don't have to be necessarily right next to each other. If I tell you, hey, these two are supplementary angles, and this one is, I don't know, 30, and I'm telling you these two are supplementary, you can already figure that out. What would that be, class? Yeah, 150, 150. Good job. Now, as we were saying, these two are supplementary because they're a linear pair. So that means to figure out what they equal, just like before, we say x plus 54 equals 180. X plus x, 2x plus 154 equals 180 minus 154. 2x equals 26 divided by 2. X equals 13. Now, x equals 13. But what's the value of each angle? Well, that's 13. That's 13 plus that. Oh, it's 54. I put 154. That's my bad. 126. So that gives us not 120s. Good job. Way to catch that, class. Good job. Divide that, you get 63. That makes more sense. So this is 63. So 63 plus 54. So this is 63 plus 54. What does that give us? 117. Yeah, you're right. 117, y'all. 117 for this angle right here. Good job, y'all. Good job. Our last thing we're going to talk about today is perpendicular lines. Very similar to intersecting in the sense that there's two lines that intersect, but they have one more specific thing. Not only do they intersect, they also form 90 degrees at the point of intersection. Okay, so these are just intersecting lines. These two are perpendicular line. This line and this line are perpendicular lines because they make the 90-degree angle. This is just an intersecting line that intersects those. All right. These two are a perfect example of perpendicular lines. Two lines that cross each other and make right angles. Right angles. So that being said, let's look at this problem right here. If that's a 90 degree, that means this is 90 This is 90, and both of these are 90. So what's the value of x then? That being said, well, like we said, both of them together make 90, so that's what we do. 2x plus 5x plus 6 equals 90. Alright, so 2x and 5x, 7x plus 6 equals 90. Minus 6 minus 6, you get 7x equals 81. Oh, 81. Wow. 84. There you go. Divide by 7. X equals 12. What's the value of y? Well, this whole thing is 90, so you'll say 4y minus 2 equals 90. Plus 2 plus 2. You get 4y equals 92. Divide by 4. What is that? 23 and 12. Easy peasy, y'all. Have any questions? Let me know. Other than that, have a wonderful day. Bye.